welcome back. Today I want us to look at our salts. It's been a long time ever since we posted, and then learners are saying like, Mwalimu, where did you go? We are back. We had a bit of hitch, but now we are back. I want us today to look at salts. Salts. This is a Form 2 topic. Salts. So we start by the definition of salts. What is a salt? A salt is a substance which is formed when the hydrogen ions from the acid are partially or wholly replaced by a cation. Cation is a positively charged ion. So this cation can be a metal cation or ammonium cation. So when the hydrogen ions have been partially replaced or wholly replaced by a cation, they form a substance which we call, remember these hydrogen ions are from the acid. So when they are partially or wholly replaced, so they form what we call a salt. For example, in this case, if I have HCl reacting with sodium hydroxide, what will happen is, now this sodium will replace hydrogen to form sodium chloride plus water. So this sodium chloride is what we call a salt. So we can also have another example, like now magnesium reacting with nitric acid. Let's say nitric acid, they give us magnesium nitrate plus hydrogen gas. So you can be able to see magnesium has replaced this hydrogen from the acid to form magnesium nitrate, which is a salt. Magnesium nitrate, which is a salt. So that is the meaning of a salt. Types of salts. We have 4 types. Number 1 type is normal salt. Normal salt. What is a normal salt? A normal salt is a salt which does not contain any replaceable hydrogen ions. Like now you can have magnesium nitrate, potassium sulfate, sodium chloride. All those ones are normal salts because they do not contain any replaceable hydrogen ions. And then number 2 is acidic salt. Acidic salt is a salt like potassium hydrogen sulfate, sodium hydrogen carbonate. You can be able to see these ones, they contain replaceable hydrogen ions. We have potassium hydrogen sulfate, sodium hydrogen carbonate, and I tend to believe in our next session we will look at how potassium hydrogen sulfate can be formed, and also sodium hydrogen carbonate can be formed. Another type of salt is basic salt. Basic salt. Basic salt, they just contain the hydroxide. They contain the hydroxide ion. That is like basic magnesium sulfate. It can be written basic magnesium sulfate. You can have basic potassium sulfate. They contain the hydroxide ions. And then another one, the last one, is a double salt. A double salt can contain either 2 cations or it can contain 2 anions. Like now you can have a salt like trona, which is sodium carbonate, and then we have sodium hydrogen carbonate, plus it contains water of crystallization. or we can river that water crystallization. This is a double salt. It contains two anions. We have the carbonate and also the hydrogen carbonate. That is our double salt. That is our double salt. So we want to look at the solubility of salts. Solubility of salts. We say this is a recap, so it's a recap, so we are not trying to rely much on salts. So solubility of salts. Solubility of salts. What you need to know about solubility of salts. We say that all nitrates are soluble. All nitrates are soluble. All nitrates are soluble. All nitrate salts are soluble regardless of the cation. All of them are soluble. We have all chlorides are soluble. All of them are soluble except all the chlorides are soluble except you have the lead 2 chloride and also silver chloride. All of them are soluble except lead 2 chloride and also silver chloride. And then you have to tell learners that this knowledge of solubility of salts, they be using them all the way from Form 2 all the way to Form 4, because that information or that knowledge is quite crucial for learners. So they have to master the solubility of salts. And then, but now the difference between the lead 2 chloride and also silver chloride is, for lead 2 chloride, it is soluble on warming. So the way you can differentiate between lead 2 chloride and silver chloride is lead 2 chloride is soluble on warming, or when you heat that white precipitate, it dissolves to form a colorless solution. And then the next one is all sulfates. All sulfates are soluble except, we have exception, that is barium sulfate, lead 2 sulfate, and also calcium sulfate. Calcium sulfate is also, it is slightly soluble, but we cannot use calcium with sulfuric acid if we want to prepare some salts, because you cannot be able to, they form white precipitates, they precipitate. And then we have the carbonates. Carbonates are insoluble, so you can be able to see the difference between chlorides and sulfates with regards to carbonates. All are insoluble except group 1, that is potassium carbonate, sodium carbonate, and ammonium carbonate, and also ammonium. All these ones, the group 1 carbonates and ammonium carbonates, they are soluble, others are insoluble. So we can, from this information, we can conclude that all sodium, potassium, and ammonium salts are soluble. They are soluble. After knowing the information about the solubility of salts, you can be able to move to solubility of bases. So if learners still have challenges in understanding and mastering this solubility of salts, they can be free to ask queries. So let's look at the solubility of bases. The solubility of bases. The bases are, a base is just like a metal oxide and also a metal hydroxide. So where we say group 1 bases, that is potassium, potassium oxide, sodium oxide, sodium hydroxide, potassium hydroxide. All these ones, they are soluble. They are soluble in water to form. When they dissolve in water, they form solutions which are alkaline. Solutions which are alkaline in a way that they turn the red litmus paper blue. So if you come to calcium oxide, magnesium oxide, and their corresponding hydroxides, they are slightly soluble. They are slightly soluble. So in the reactivity series, all the bases below magnesium, the oxides of metals below magnesium, they are insoluble. You talk of lead 2 oxide, calcium, lead 2 oxide, the likes of copper 2 oxide, all those ones, they are insoluble. Methods of preparing salts. Methods of preparing salt. So for you to be able to prepare salt, you have to know which type of salt you are preparing. Remember, we have soluble salt and also insoluble salt. There are different methods of preparing soluble salts and also insoluble salts. So we start with soluble ones. How can we be able to prepare soluble salts? Soluble ones. Number one is through the reaction between sorry, I'm trying to squeeze because my board cannot be able to fit in all those information I'm saying. Some of the information I'm not writing it because I tend to believe you can understand it, and also the board is not sufficient. So the reaction between a metal and acid, a metal and an acid, that's one method of preparing soluble salt. For example, if I have magnesium reacting with dilute HCl to give us magnesium chloride plus hydrogen gas. And then when you are writing the chemical equations, they have to be balanced. A chemical equation is not an equation, number one, if it is not balanced, and also if it does not have the correct state symbols. So that's number one method we can use to prepare soluble salt. If you have a metal and a dilute acid, you react them, they're gonna give you a soluble salt. So we have, of course, we have exceptionals. We cannot use calcium with dilute sulfuric acid because it will form an insoluble salt. So calcium metal plus dilute sulfuric acid cannot be used to prepare soluble salt. And also number two is a reaction between a base plus the acid. A base and an acid, which we normally call neutralization reaction. A base and an acid where salt and the water are prepared as are being produced as their own product. So like now we can have sodium hydroxide plus dilute nitric acid to give us sodium nitrate plus water. Sodium nitrate plus water. That's another way of preparing soluble salt, through a carbonate and an acid where water, salt and carbon 4 oxide are being produced as the products. So we can have calcium carbonate. We are using this one smudge. We can have copper 2 carbonate plus dilute HCl to give us copper 2 chloride plus water plus CO2. This is a gas, liquid, aqueous, and then aqueous. This is a solid. That's another way of preparing soluble salt, through the reaction between a carbonate and a suitable acid. That's where we are getting it wrong. Must be a carbonate and a suitable acid. When we say a carbonate and a suitable acid, we mean that you cannot use calcium carbonate with dilute sulfuric acid to prepare soluble salt, because we all know what will happen. You cannot use lead 2 carbonate with these two acids, dilute HCl and also dilute sulfuric acid. Why? Because they form insoluble salts. We have also others like barium carbonate, which you cannot use with dilute sulfuric acid. Direct synthesis. Direct synthesis. Direct synthesis. Direct synthesis is also called direct combination. Direct combination of elements, where you take in two elements, you react them together to give you a salt. Like now, if I have a sodium, I can react it with chlorine gas to form sodium chloride. That is what we call direct synthesis. Or you take magnesium, you react it with chlorine gas to give you magnesium chloride. So that is also direct synthesis or direct combination of elements. What are the methods of preparing insoluble salts? Insoluble salts, we have few methods of preparing them. Number one is through direct synthesis or direct combination of elements. Number two is through precipitation. Or we call it double decomposition. We have precipitation or double decomposition. Precipitation reactions are those reactions where we take two soluble salts, we react them to give us one insoluble salt and the other soluble salt. Like that one, for you to be able to write those reactions, you must have the knowledge of solubility. That's where now solubility of salts comes in. So if I have we know all sodium salts are soluble, so I can have sodium chloride, which is aqueous. I react it with another soluble salt, but which in turn will combine with this chloride to form an insoluble. Which one is that? We can use lead 2 nitrate, like that. It will give us, remember this one is soluble and this one is soluble. It will give us, now they interchange the anion, or the ions, they will interchange the ions. So we will have lead 2 chloride plus sodium nitrate. You balance the equation, the state symbols. This one, all chlorides are soluble except lead 2 chloride. This one is a solid, this one is aqueous, and then unaweka tu hapo, your equation is balanced. So this is what we call precipitation reactions or double decomposition. You can have another example. We know now, using the knowledge of solubility of carbonates and also the solubility of which one? Nitrates. Let's say nitrates. I can have a potassium nitrate, which is aqueous. Not this one, but I can use, let's say we said all group 1 carbonates are soluble, so I can have potassium carbonate, which is aqueous, plus, let's look at the nitrate, which is soluble, but it's not of group 1. Yes, calcium nitrate. We can use calcium nitrate. So what we are going to have, they interchange the ions. Tutakuwa na carbonate plus potassium nitrate. You balance state symbols. This one is aqueous from the information, the knowledge of all nitrates are soluble. Even this one is aqueous. All carbonates are soluble. All group 1 carbonates are soluble. The other carbonates are insoluble. So this one is, that one is a solid. So that is another method of preparing this one, these salts. So how can I obtain these salts? So after the reaction, what follows is filtration. We have also those questions which tell you, starting from copper metal. Starting from copper metal, explain now crystals of copper 2 sulfate will be prepared. Explain how the crystals of copper 2 sulfate will be prepared. You must have the knowledge of the solubility of bases, where you know that now, or you have to know that copper is below hydrogen in the reactivity series. If copper is below hydrogen in the reactivity series, it cannot be able to react with dilute acids. So you start from copper. You have been given copper metal, and then you are required to prepare copper 2 sulfate crystals. We say crystals, those ones are blue, they contain the word of crystallization. So starting from copper, can you explain how copper 2 sulfate crystals will be prepared? We are saying that now you cannot directly have the reaction between copper and diluted sulfuric acid to give you copper 2 sulfate, because we know copper is below hydrogen in the reactivity series. So when copper is below hydrogen in the reactivity series, it cannot be able to displace hydrogen from that acid. So we cannot have a reaction between copper and also dilute sulfuric acid. We cannot have a reaction between lead and also any dilute acid, because they are below hydrogen in the reactivity series. So what are you supposed to do? First, you heat this copper. You react that copper with oxygen. You burn it or you strongly heat it in an open crucible, where it is going to combine with oxygen gas to form copper 2 oxide. This is where we start from. So first, heat copper in an open crucible, where it's going to combine with oxygen to form copper 2 oxide. From there, now this is a base, but this base is insoluble. So we said we cannot have a reaction between a base, an insoluble base, and an acid. It will still give you a salt. So from this, we are going to react copper 2 oxide plus 2 oxide with the dilute sulfuric acid, H2SO4, to give us, this is aqueous, this one is a solid, to give us copper 2 sulfate plus water. Remember, this is a reaction between a base and an acid. The reaction between a base and an acid, it will give you copper 2 sulfate and water. From there, but remember this one will be a solution. It will be a solution. So how will you get copper 2 sulfate crystals? And then you heat the mixture to saturation. You heat the mixture to saturation. Why are we heating the mixture to saturation? So that you can be able to form crystals. You heat to saturation and you allow it to cool. The crystals will be formed. After the crystals have been formed, you can be able now to dry them between the filter papers. But if you are being told how assemble of copper 2 sulfate powder or anhydrous is the one which does not contain water of crystallization, then you can be able to heat to dryness. Heat to dryness to ensure that now all the water has been eliminated.